In the last lesson, we started using the distributive property when we were multiplying radicals. Now we want to look at multiplying a binomial times a binomial. Remember what this means. We have to take the first term, root 2, and multiply it by both terms in the second bracket. So let's rewrite this. Root 2 times the second bracket plus root 7 times the second bracket. Now we're just using the distributive property again. And you know, I often find these arrows helpful because sometimes people forget to multiply the second term. These are all prime numbers, nothing to simplify. Root 2 times root 3 is root 6. Root 2 times root 5 plus root 10. Positive root 7 times root 3 plus root 21, positive root 7 times plus root 5 plus root 35. These are not like radicals. They cannot be simplified any further. We are done. In question 2, let's open that bracket again and rewrite the question. In question 2, I see that there will be common factors. When I multiply root 6 by root 3, I know that 3 is going to be common. So let's prime factor. When I multiply root 6 by root 10, I know that 2 is going to be common. Now, root 3 times root 3, we know that root a times root a equals a. And in root 3 and root 10, there are no common factors. 10 has 2 and 5, not a 3. So negative root 3 times root 10 will be negative root 30, and it can't be simplified any further. If that was all difficult for you, rewind, listen again, rewind, pause, try it yourself, and then continue on. 2 factors of 3 can be taken out. 2 factors of 2 can be taken out. So we have 3 root 2 plus 2 root 15. There's a 3 and a 5 left there. Minus 3 minus root 30. There's a lot going on in those questions. They take some practice. So, 2 questions for you to try. Pause your video. So in question 3, we opened the brackets and we had 4 times the second bracket plus root 10 times the second bracket. 4 times 7 is just 28. 4 times negative root 15 will just be negative 4 root 15. Remember, you can't combine them. 4 is not inside a radical sign. Same thing with root 10 times 7. But I noticed when I was multiplying root 10 by root 15 that there would be a common factor of 5. In fact, we see it here. We can take out that 5. So our final answer, 28 minus 4 root 15 plus 7 root 10 minus 5 root 6. We don't have like radicals here. We can see that we're finished. If you haven't already done so, finish question 4 and question 5. This question was interesting. I hope you thought so as well. Root 7 times root 7 we know is simply 7. Root 7 times root 5 is root 35. Negative root 5 times root 7 is negative root 35. And negative root 5 times root 5 will be minus 5. We see that our middle terms subtract out, and we're left with 7 minus 5 or 2. Did you get that? Interesting. Did you recognize that this was in the form a minus b times a plus b. Interesting. We know that that should give us a product of a squared minus b squared. Well, let's think about that. If a is equal to root 7 and b is equal to root 5, root 7 squared minus root 5 squared equals 7 minus 5, or 2. These are known as conjugates. When the sign in the middle changes, one is a plus, one is a minus, we get that a minus b times a plus b. Keep your eye open for those. Use the formula. Now, I also asked you to do question 5. So I opened the brackets, root 8 times the second bracket minus root x times the second bracket, but then I simplified the square root of 8 because I knew it had no factors in common with anything else, but I also knew, because I've been practicing a lot, that I could simplify that radical. I hope you did as well. Even if you didn't, your final answer should be the same as mine. Now we have 2 root 2 times root 3. The 2 multiplies 1. Root 2 times root 3 is root 6. 2 root 2 times root x plus 2 times root 2x minus root x times root 3 minus root 3x minus root x times root x. That simply equals x. We have no like radicals. This question is finished. Did you recognize that we have conjugates for question 6? A equals 2 root 3, b equals the root of 8. I just simplified the root of 8 over here. Did you simplify the root of 8? Let's assume you did not. In fact, for this question, maybe it's easier not to. Let's find out. So we know that this should be a squared minus b squared. We have 2 root 3 times 2 root 3. Root of 8 times the root of 8. We know that. It equals 8. What about 2 root 3 times 2 root 3? 2 times 2 is 4. Root 3 times root 3 is 3. So this gives me 12 minus 8, which equals 4. How about a little bit more multiplication? You know how to square a binomial. Pause your video. Do questions 7 and 8. I hope you understood that means root 3 minus root 5 times root 3 minus root 5. The sign did not change. This exponent tells me I multiply everything in the bracket by itself. Do not change the signs. If you are, then you're not squaring that binomial. The signs shouldn't have changed. Some of you know a formula for squaring a binomial, and you certainly could have used that here, but I think most of you need to practice multiplying all types of binomials, not just perfect squares, as long as you remember that that sign in the middle stays the same. So when we open our brackets, root 3 times root 3 is, of course, 3. And then root 5 times root 5 will be 5. we had like terms here. Minus 2 root 15, and then 3 plus 5 is 8. If you haven't already done so, finish question 8. So this time in multiplying our binomials, we had root 2 plus root 6 with a plus sign in the middle. That plus sign should have stayed the same in both of these. I hope you noticed when we were using the distributive property that root 2 times root 6 had a common factor, so I prime factored. Same thing here, I prime factored. We saw that there was 2 factors of 2 that could come out both times. And then we had like radicals that we could combine to give us 8 plus 4 root 3.